Lindsay, I'm gonna use this document camera here to try and show you how I see this trick as working, and hopefully I can explain it well enough through a webcam. So here's the way it's set up, and you know the trick obviously, but you start by flipping over a card, and whatever that card is, you start counting up. So if you flip over a 6, you start counting at 6, go 6, 7, 8, 9, 10, 11, 12, and stop at 13. Then you flip over another card. So each pile ends up having, wherever you start from, up to 13. The way it always works out is that we'll go with maybe pile 1. We'll call this pile 1. Pile 1 is going to be some number that you flip over. So I'll say X because it's X. And actually, I haven't written this down for a little while. I'm going to start that over. So pile 1 is going to be X, but the number of cards in that pile is going to be 14 minus X. So let's go with my number 6 as an example again. So if I flip over a 6, there'd be, and you can count on your fingers if you need to, it'd be 6, 7, 8, 9, 10, 11, 12, 13. There'd be 8 cards in that pile, including the 6, because that's part of the pile. So it's like you're counting 0. And so 8 and 6 would give you the 14. If you flip over a 9, you'd have 9, 10, 11, 12, 13. You'd have 5 cards in that pile, including the 9. And 9 plus 5 is 14. So pile 1 is going to have 14 minus whatever number I flip over. A 6, for example, you'd have 8 cards. 9, you'd have 5 cards. So it's 14 minus X. All right, so that's pile 1. Let's keep going. We got pile 2. We'll flip over some other card. We're going to have 14 minus Y cards in that pile. Keep going. Pile 3, you're going to have, same idea, you're going to have 14 minus, we'll go Z cards in that pile. And I'm going to stop there. And that's one thing that tripped me up for a little bit when I was thinking about this problem is that, yeah, you keep going with your piles. However, once you've made all your piles, even if there's a remainder, you ask the other person to flip 3 piles over, and you just collect all the other ones into one pile. Since it doesn't matter which pile your partner, whoever it is you're doing this with, flips over, you could rearrange those piles however you want. And so whether they flip the first 3 piles or the first, second, and fifth pile or whatever, you can rearrange those piles. And so it doesn't matter which pile it is. So I'm just going to say it's pile 1, pile 2, and pile 3. And then you would have everything else. And I'm just going to use R for the remainder, because you're going to put all the rest of the cards into one pile. And that'll be the remaining pile. Okay, so you've got the remainder. You got everything except for what was in the 3 piles that the person flipped over. Plus you've got this pile 1, 14 minus X. Plus you've got this pile 2, 14 minus Y. And you've got this pile 3. And if you take the 3 piles that somebody flipped over and all the other cards that they didn't flip over, you put them into a pile, together you should get 52 cards, because that's everything. That's all the cards. Okay, this is it. This is the formula. This equation right here represents the entire trick. After you've flipped over the cards and you've made your piles, and you say, okay, flip through whichever 3 piles you want over, they flip 3 piles over, and you collect the rest of them into one pile, this is what you have. And now it's just a matter of rearranging the numbers to finish out the trick. So if I get rid of the parentheses, I have R plus 14 minus X plus 14 minus Y plus 14 minus Z. I don't have to worry about distributing for any of those, so we're good there. If I combine like terms, I've got 14, 14, and 14. So that gives me the remaining plus, what would that be? 42 minus X minus Y minus Z. That's 52. Hopefully I'm not going too fast here. You're following me. And here, if I subtract 42 from both sides, actually, I take that back. Let me stop and say, let's assume that the person you're playing against flips over, because I think at one point you need them to flip over the top cards from piles. We're going to assume they flip over 2 and 3, pile 2 and pile 3. It doesn't really matter, X, Y, Z, because that's just random numbers. But we're going to assume that they flip over pile 2 and flip over pile 3, which leaves pile 1 alone. And that'll be our last card that they flip over. So if I want to get X by itself, because that's the card I want to have last. So they flip over that last card, and oh my goodness, that's how many cards are left over in my remaining pile, because that's what we're really shooting for here is how many cards are left in this remaining pile should be the same as that number X. So I'm actually going to subtract the 52 from this side, and I'm going to add the X. I'm doing 2 steps in one here, but hopefully you can follow that along. So 42 minus 52, we'd have R minus 10 minus Y minus Z equals X. Now you should see some familiarity here with the problem. If you take what was in your remaining pile, remember you had that big pile of everything except for what was on the board, those 3 piles, that remaining group, and you always put 10 aside. So we take our remaining pile, we take out 10, put those to the side. And then you have them flip over. You have them flip over the top card in pile 2 and the top card in pile 3, or well, it doesn't matter, right? So you flip over the top card and the top card. Remember those top cards, that was the one we started with, Y and Z. So you flip those 2 over and you add them together, and then you take those out. Well, that's what we have right here. You could even pretend that there's a parenthesis you could distribute the negative through. If you add those 2 other piles together and you take that out, what you're left with is that number X. Now, I don't know how good a job I did of explaining this without having to take the cards and without running through the problem in front of me, but if you have that remaining pile and you take out 10 cards and then you take out the sum of 2 of the piles, you get the remaining pile. And it works out every time. So no matter what numbers you choose for X, Y, for X, Y, and Z, whatever flips over for those 3, the rest of them don't matter, you're always going to get this remaining if you take 10 cards out and then you take out the sum of those other 2 cards. So it does work, works every time. You can manipulate this problem pretty easily. If you want to take out the face cards, this would turn into 40 because you'd take out 12 of the cards. And instead of going up to 14, you would have 11. So it'd be 11 minus X. And then you could do the exact same equation. And you'd end up with, I think instead of taking out 10, you'd take out like 7. Yeah, sounds about right. And so it just changes the problem ever so slightly. You could even have somebody say, you could ask them to pick a number that you're supposed to count up to. So instead of counting up to 13, they could ask you to count up to 17. You could say, pick a number between 13 and 20. I'll count up to that. The only thing that would change is I think if you had to count up to 18, 19, or 20, I think instead of having 3 piles, you have 2. But yeah, this is a fun trick. I was really excited about it when you showed it to me, and it will work. And here, hopefully, is the explanation for you.